Welcome to Honey of Knowledge. This is Ashish Gourav, and today let's discuss something about equilibrium in social interactions. Do you remember the movie A Beautiful Mind? Yeah, John Nash movie. So in that movie, there's a scene in which three, four friends are sitting and discussing whether to approach a blonde, beautiful woman or not. And John Nash, who was among them, suddenly had an epiphany. And the epiphany was like this, that why should we approach the blonde woman? She is anyway above their league. So let's approach the other girls and make our chances high. Now, a lot of people, after watching this, think of this as a Nash equilibrium, but it's not. Because if you remember what's Nash equilibrium, it's a situation in which the strategic interaction of players or agents is such that none of the agents can single-handedly or unilaterally deviate from that situation to benefit. Or rather, if let's say you have five players playing a game, and if any four of them, do not change their strategy or decision or way to play, the fifth person, if he can deviate and benefit, then it is not a Nash equilibrium. But if he is not able to benefit after deviating, it is a Nash equilibrium. So essentially, it's a case of no unilateral profitable deviation or no single-handed profitable deviation of n players or any number of players. So let's simplify the John Nash situation or a beautiful mind scenario. So let's say you have three friends and they are putting 50 value. I mean, we tend to think in terms of utility in economics, but let's say it's some kind of a notional value 50 when they approach a blonde woman and she accepts their proposal. And similarly, a utility or a notional value of 10 is attached to approaching another girl and she accepting their proposal. So how can you model this? Now let's take rest of the friends one agent. Now this is a very vague kind of a thing and not uh, a perfect way to represent Nash equilibrium situations or game theoretic models, but we will take this just for the time being. And this represents John Nash. So let's say all of them approaches blonde, and even John Nash's approaches the blonde. Now, obviously, as per John Nash's theory, nobody will get the blonde. So 0 0. Now, idea here is you need to understand how this matrix is. The first number corresponds to the rest of the friends, and the second number corresponds to John Nash. So if you check this situation, when the rest of the friends are going to the blonde, but John Nash is avoiding the blonde, so it is 0, 10, or rest of the friends get 0 and John Nash is getting 10. Now let's take another situation. When rest of the friends are avoiding blonde and John Nash is also avoiding the blonde, in that case they're approaching other girls. Now if they're approaching other girls, they get a utility of 10. So John Nash will get 10 and the other folks will get 10 each. So 10 plus 10, that will be 20 because we have two friends apart from John Nash. Now let's say we take the situation of John Nash avoiding the blonde, John Nash going to the blonde and other folks avoiding the blonde. So if other folks are avoiding the blonde, they will get 10 each. So 10 plus 10, 20. But John Nash, being the single person approaching the blonde, will definitely be accepted and he will get a 50 reward or rather a 50 notional value. Now over here, I claim that this is the Nash equilibrium. John Nash going to the blonde and rest of the friends avoiding the blonde. But anyway, the Nash equilibrium quoted by John Nash in the movie, which is avoiding the blonde by all of them, even John Nash, is certainly not Nash equilibrium. Let's see how. This 20,10 is the touted equilibrium in the movie. Now, let's consider John Nash and rest of the friends are staying put at their decision of avoiding the blonde. Now, very simply, John Nash can jump from avoiding the blonde to going to the blonde and get a benefit of 40, 10 to 50 because he is moving horizontally. None of the other players are moving. So the game goes from 20,10 to 20,50. So this is how John Nash can benefit from deviating from this touted Nash equilibrium of everybody avoiding the blonde. So certainly the movie is not accurate if they want to show that this is a Nash equilibrium. But I don't think the movie showed that. Only few people who are enthusiastic they describe it as a Nash equilibrium.